Before time began, before space had depth or direction, there was no light, no darkness, no matter, and no emptiness to contain matter. Everything that ever existed was compressed into a state beyond human imagination, a singularity of infinite density and temperature, where the laws of physics as we know them completely broke down. There was no before. Time had not been born. Space had not unfolded. Every possibility of reality lay silent. Then the unimaginable happened. Approximately 13.8 billion years ago, an event later called the Big Bang occurred. It was not an explosion in the ordinary sense. There was no sound roaring through emptiness. It was the expansion of space and time themselves. In a fraction of a second, cosmic inflation began, expanding faster than the speed of light, magnifying tiny quantum fluctuations into the seeds of future galaxies. The temperature was so extreme that no familiar form of matter could exist. The four fundamental forces may once have been unified before separating as the universe cooled. Within a millionth of a second, quarks combined to form protons and neutrons. 3 minutes after the Big Bang, primordial nucleosynthesis began. Protons and neutrons collided and fused, forming the nuclei of hydrogen, helium, and trace amounts of lithium. These were the first elements, the foundational building blocks of every star, planet, and living being. Yet the universe remained an opaque ocean of plasma. Light could not travel freely. It took about 380,000 years for the universe to cool enough for electrons to combine with nuclei. Only then could light move freely through space. That ancient light still exists today, as the cosmic microwave background, a faint echo of the first moments, mapped by modern telescopes. After light was released, the universe entered the Dark Ages. There were no stars, no galaxies, only vast clouds of hydrogen and helium drifting through immense darkness. But gravity was quietly at work. Slightly denser regions began pulling in more matter. Over hundreds of millions of years, gas clouds collapsed, heating up until nuclear fusion ignited in their cores. The first stars were born. They were larger, hotter, and brighter than our sun. In their cores, hydrogen fused into helium, releasing tremendous energy. When their fuel ran out, massive stars exploded as supernovae, scattering heavier elements like carbon, oxygen, and iron into space elements essential for life. Each stellar explosion wrote a new chapter in the chemical story of the universe. From the earliest star clusters, galaxies formed. Under the influence of gravity and dark matter, increasingly complex structures emerged. Spiral galaxies, elliptical galaxies, and vast galaxy clusters connected in a cosmic web, like luminous threads woven into the fabric of space. In a modest corner of a spiral galaxy, later called the Milky Way, about 4.6 billion years ago, a cloud of gas and dust collapsed to form a new star, the Sun. The remaining material swirled around it, colliding and merging to form planets. Earth was born from fragments of rock and metal, at first a molten world bombarded by meteorites. Over hundreds of millions of years, Earth cooled. Water vapor condensed into oceans. In warm primordial waters, complex chemical reactions led to the formation of the first self-replicating molecules. From single-celled organisms to multicellular life, from fish venturing onto land to dinosaurs, and eventually mammals, evolution unfolded on a planet orbiting an ordinary star in an ordinary galaxy. And then, in a moment, insignificant compared to cosmic history, humanity appeared. We looked up at the night sky and wondered about our origins. Those distant points of light were not lanterns. They were vast nuclear furnaces, planetary systems, perhaps even worlds harboring life. Every carbon atom in our bodies was forged in a dying star. Every iron atom in our blood was born in a supernova explosion. In a very real sense, we are stardust that has learned to think. The universe continues to expand. Observations suggest that this expansion is not slowing down, but accelerating, possibly driven by a mysterious force called dark energy. The distant future may be a cold, fading universe where stars burn out and galaxies drift apart. Or perhaps there are destinies yet unknown to science. Whatever the ultimate fate, the story continues. From an unimaginable singularity, the universe has grown into a vast expanse, containing hundreds of billions of galaxies, each with hundreds of billions of stars. Within that immensity, life emerged, consciousness awakened, and for the first time, the universe gained the ability to contemplate itself through human eyes. The Big Bang was not merely a physical event, it was the beginning of every story, every atom, every heartbeat. It was the origin of light, of time, of the very question we now ask. And when we study the cosmic microwave background, observe distant galaxies, or simulate the first seconds of existence in particle accelerators, we are tracing the echoes of that primordial moment, the moment when nothingness became existence. In the profound silence of space, light from ancient galaxies still travels toward us, carrying messages from billions of years ago. Every photon is a memory, every star is a chapter, and the universe itself is a grand epic that began with a whisper of energy, a whisper that became everything.